Hello everyone, welcome to the next session on ANSYS CFD tutorials. In this session, we will analyze the NACA2414 airfoil for its drag and lift while considering an angle of attack of 10 degree. We will start by double clicking on Fluid Flow Fluent. I have already created the geometry. You can go through the video, so I'll directly import the geometry here of the airfoil. Then I'll double click on geometry. When I created the aerofoil, I have given extrude on both the sides. So I'll just go and change this to add frozen. Here I'll change both symmetric to reversed and depth I'll give as 250 mm and generate. So this is the aerofoil which is required. Now I will click on XY plane look at such that it becomes perpendicular to the screen. Now I'll go to sketch once again. And here I am going to draw the boundary box for the airfoil. Then I'll go to modify and choose trim. Then I'll go to dimensions and give dimension to this line, to this one, this distance and this distance. H1 I'll give as 200. L3 I'll give as 50. V2 I'll give as 100 and L4 as 50. Next I'll go to modeling. Then I'll click on extrude. I will select the new sketch that I have made, apply. I'll choose add frozen and here I will give a depth of 250 mm, that is the span of the airfoil, and generate. Now once this is done, we will have to give an angle of attack. So I will go to create, body transformation, rotate. This is asking for the body, so I'll select this airfoil. Now here I can't select, so I'll just select from here, apply. Axis is the XY axis about which I want to rotate this airfoil, apply. Here I'll give the angle as 10 degree and generate. Now you can see that the surface is still remaining, so I'll just go to surface body and I'll suppress the body. You can still see the line body, so I'll just suppress the line body as well. Now what you can see is the airfoil which is at an angle of 10 degree. Now I will go to create and choose boolean. I will shift from unite to subtract. Target body is the outer body. Tool body is the airfoil. Apply and generate. So here you can see this is the shape that we need for analysis. So once this is done, I'll close this. Then I'll go to mesh and double click. Now I'll go to mesh and I'll change the sizing to 0.01 meter and generate. So you can see the meshing is done, but I will still change the meshing a bit. I'll refine it. So I'll insert sizing. I'll select the airfoil portion, that is the geometry. Element size here I'll give as 0.01 and generate. So you can see the meshing is done, but it is still not fine. So I will again go to the space meshing and I'll change the size to 0.001 meter and generate. You can go to mesh and see how beautiful the refinement has been done. You can also change the refinement overall on the body, but I'll leave it as it is because that is not my requirement. I'll go to this side, right click, create named selection. I'll change it to inlet. This side is the outlet. This side and the side opposite to it, right click, create name selection is the symmetry one. And these two sides are symmetry 2. So once this is done, the naming is complete. You can check the naming over here, inlet, outlet, symmetry 1 and symmetry 2. So just go to mesh and update once again. Here you will get the message that the mesh translation to Fluent was successful. So now this can be closed. Now I'll go to setup and double click. I'll choose double precision and solver processes. I'll choose 2 and start. First we'll go to model. Here you can see in viscous, the model has been chosen as SST K omega. So I'll leave it to as it is. You can change the model if you want. Next, material for fluid, it is already air, so you don't have to choose anything else. Then I'll go to boundary conditions, inlet condition. Here I'll go to inlet. I'll give the value of velocity as 15 meters per second. Apply and close. Next I'll go to reference values. I'll compute from inlet. Reference zone is a solid. Next I'll go to monitors. Here I'll go to report plots. I'll click on new. Here I'll select new, force report, drag. Here I'll write down drag, CD. I'll select wall solid. Here I'll tick print to console. OK. Then I'll click on new, force, lift. Here I'll write down lift, CL. Wall solid is what I'm going to choose. Print to console. OK. Once this is done, I'll click on OK. All three have been selected. Close. Then I'll go to initialization and double click. I'll choose hybrid initialization and click on initialize. You can see here hybrid initialization is done. Then I'll go to calculation activities, auto save and double click here. I will give the value as 20 and click on OK. Then I'll go to run calculation and double click. Number of iteration I'll give as 500 and click on calculate. The calculation is complete. Now here you can see this is the drag plot here. The maximum value of drag can be seen here. It is 0.003. In the lift plot, you can see the coefficient of lift CL is 0.0398. Here also you can see the solution is converged at the 74th iteration. This will help you figure out the coefficient of lift and drag. You can see here this is the value of CD, maximum is 0.003, and here is the value of CL. So once you have figured out these values, this is done. So I will close this window. Okay. We'll go back to the main screen and double click on results. First we'll go to streamline. Okay, I'll start from symmetry 1. Number of points I'll give as say 70. Apply. So here you can see the streamlines that are formed. Here there is a little bit of vortex which is formed at this end. Now I will give this number of points as 50 and apply. So you can see that this streamline passes well over this aerofoil. We'll go to animation. I'll choose sweep animation, streamline 1, remove the forever loop and give 3 loops here and run the solution. So you can see here how the air will flow over this aerofoil. Now the size of these particles that we have created, that is a ball, is quite larger. So I'll change this to 0.5. Also I'll slow down the speed and then animate once again. So now you can see here how it is moving past the airfoil. You can see the maximum velocity is 28.22 meters per second. Minimum value is 0. At this zone the velocity is the highest. That is why it is shown in red color. So we'll close this now. I'll untick the streamline. I'll go to contour. Okay. I'll choose the location as symmetry 1. This is the pressure contour that we are creating for the local values. Number of contours I'll give as say 100. These are the points. I'll go to render and remove the show contour lines. I'll click on apply. So here you can see the beautiful pressure contour which has been created. At this zone the pressure is maximum, that is 166.433 Pascal. That is in this zone. And here it is minimum in blue color, that is minus 489.36 Pascal. So once you have created this one, you can untick and create another contour of velocity. Location is again symmetry 1. I'll change variable to velocity, range to local, number of contour points as 100. I'll go to render, remove show contour lines and click on apply. So now you can see here the velocity is 0 almost in this zone, to quite an extent over here also, and the air is flowing over it very easily. Here the velocity is higher, it is 2.735 into 10 raised to 1, that is 27.35. And here also you can see it is 28.2 to be precise meters per second over here. And the minimum value is 0, which is in blue color. So that's how you can see that when the angle of attack for this aerofoil changes. Initially we have analyzed for 0 degree angle of attack, which means the aerofoil is horizontal perfectly. At that time you have seen one result. Now you can compare the same result which we have got over there with this result, such that you understand what is the pressure and the velocity variation over the aerofoil. Now here the value of lift that we had got was higher and the drag was low. So that means that the aerofoil is going to experience an upward motion. The lift is more. So the positive angle of attack anyway shows that the aerofoil is moving upwards. And the angle of attack should be between 0 to 15 degree, because above 15 degree the aerofoil gets stalled. So what we prefer is between 0 to 15 degree only for this angle of attack. So with this I end this session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.